For today, let's look at this interesting question regarding polynomial. Here's the question. Find all pairs of integers a, b such that the polynomial ax power 9 plus bx power 8 plus 1 is divisible by x squared minus x minus 1. Please have a good try before you look at the answer. My first intuition for this question is that AB may be just some integers 1 or negative 1. However, when I look at the expression x squared minus x minus 1, then I change my mind. Intuitively, I guess the answer AB may be related to the Fibonacci number. Let's start doing it now. Suppose PQ are roots of x squared minus x minus 1 equals 0. Then from the condition that ax power 9 plus bx power 8 plus 1 is divisible by x squared minus x minus 1, we know that PQ are also the root of ax power 9 plus bx power 8 plus 1 equals 0. From the previous condition, we know from Vieta formula that the sum of roots p plus q equals 1 and the product of roots pq equals negative 1. And from this condition, we know that each of the pq satisfy the equation. Namely, ap power 9 plus bp power 8 plus 1 equals 0 and aq power 9 plus bq power 8 plus 1 equals 0. Multiply each term in equation 1 by q power 8. Then we obtain AP power 9 q power 8 plus BP power 8 q power 8 plus 1 times q power 8 equals 0. Since PQ equals negative 1, then we know that PQ power 8 equals 1. So the equation becomes AP plus B plus q power 8 equals 0. So we label this newly formed equation as equation 3. Using the similar argument, we multiply each term in equation 2 by p power 8 and we obtain aq plus b plus p power 8 equals 0. Let's call this equation as equation 4. So equation 3 minus equation 4 give us a times p minus q plus q power 8 minus p power 8 equals 0. This means that a equals p power 8 minus q power 8 over p minus q. Note that p power 8 minus q power 8 equal the square of p power 4 minus square of q power 4. It can be factorized as p power 4 plus q power 4 times p power 4 minus q power 4. Using the similar argument, p power 4 minus q power 4 can be written as p squared plus q squared times p squared minus q squared. And finally, p squared minus q squared equals p plus q, p minus q. Then we know that a is actually equal to p power 4 plus q power 4 times p power 2 plus q plus 2 times p plus q. Using the condition that p plus q equals 1 and pq equals negative 1, then we know that p squared plus q squared equals square of p plus q minus 2pq, which is equals to 3. Then we use a similar argument to obtain the value of p power 4 plus q power 4, which is equals to square of p squared plus q squared minus 2 of pq squared. And we obtain 7. Then we continue for p power 8 plus q power 8, and we obtain 47. Using the value that we obtained just now, then we know that a is 7 times 3 times 1, which is 21. In order to obtain the value of b, we consider equation 3 plus equation 4. And this will give us a times p plus q plus 2b plus p power 8 plus q plus 8 equals 0. We substitute the value and the direct calculation gives us b equals to negative 34. As mentioned in the beginning of the video, AB may be related to the terms in Fibonacci sequence. Let's look at the Fibonacci sequence. Then we find out that indeed 21 and 34 are two consecutive terms in Fibonacci sequence. In fact, this question can be generalized to ax to the power of n plus 1 plus bx to the power of n plus 1 is divisible by x squared minus x minus 1 if and only if a and negative b are both two consecutive terms in Fibonacci sequence. Hope that you have learned something new today and enjoyed this video. That's all for today's lesson. I'll see you again next time. Bye bye.